So thank you everyone for coming. I'm Vittorio Giovara. And I will be talking about Vimeo and the open source community. I would like to thank you, the EBU, and for having me here, and the FOSDEM staff for letting this event happen as well. And of course, my colleagues that helped me to draft the slides. So this presentation is split into two main parts. The first one is about our architecture, our infrastructure, and the second part is more about our open source philosophy. Sure. So what is Vimeo? Vimeo is a video streaming website. We are amongst the top 5 video streaming services. We are content creators. We multimedia hackers. We like to experiment new things and new technologies. We believe that the highest quality of video is a nice asset for us, and we do that by having a very clean playback, full HD playback with no advertisement, and we help the both audiences and the creators to get revenue from through our services with either Vimeo on demand or with the tip jar, which are all tools for helping people spread their videos. Everyone uses us, and I invite you to visit the site to know more. So our architecture is mainly based on microservices. This is how we handle static images and thumbnails. We have a selection of processes that help us abstract and compress the images. On the top right, we see Hadsucker and Guzon, which are two tools for abstracting, accessing storage from the CDN, from the computer infrastructure, and Hadsucker helps us to cache the results. For example, if an image has been requested very recently, it will not get downloaded again, but it will be provided through the cache. And the main point of this scheme is the ViewMaster. ViewMaster is our tool that is able to decompress any kind of images, and will store the original in WebP lossless, and then we'll be able through Guzon and Hadsucker will provide either PNG, JPEG at any resolution, or even WebP if the browser supports it. I started with the images because it's the simplest scheme possible. I will move to videos. Video transcoding is very complex, but we have a streamlined architecture infrastructure that helps us deploy it. We have again some abstractions with, for example, Varnish and Gearman to help us cache and deploy jobs to different computer engines. We, as you can see, we encode the audio and video separately, and then we multiplex later. We have a job scheduler and metadata analyzer in order to have some valid data before starting a new job. I will go in more detail now. We have this is a zoom in of a Gearman job. We have the master job, which controls everything, and it is master that calls for the asset fetcher. Asset fetcher will download the file from once uploaded from the storage to our encoding platform. We have the asset analyzer, which is a collection of FFF probe and email and media info, which take the file and do perform some image color space analysis. We have FFMS2 also for frame rate analysis and indexing. Once we have everything and everything is valid, like we support the coding this, we send the job to Jitter. Jitter is basically a wrapper for FFmpeg. It's FFmpeg receives the two requests for encoding audio and video. Once this is successful, it will return back to master, and then master will also, to Jitter, and Jitter will send the two streams to LSMesh. LSMesh is our favorite MP4 muxer. Once the MP4 is ready, we have a small validation process which checks that what has been encoded matches what has been received on input. Then it is uploaded on the CDN. The CDN then replies when we get the reply from the CDN, we have to update the application, which is the HTML web page, that the job is finished. We do that through an HTTP post, but since it can fail, we also use some queuing services. As you can see, these are small services. We use many more, but these are particularly interesting because they are deployed mostly with the open source tools. These are mostly what we use. We have, of course, Gearman for having a distributed server. We use FFmpeg and libav, which are the best multimedia toolkits available. X264 does need no presentation, I guess. LSMesh is, as I mentioned, is our favorite MP4 muxer and also MP4 analyzers. Worth noting also FFms2, which is has simpler APIs than libav codec, and is really simple to use. FDK ASC is how we encode the audio. Media info, as I mentioned, about analyzing the video is really important to have a separate tool for that. And of course, many packages for Go. Most of our tools are written in Go, and there is an ongoing process to ditch any Python and JavaScript-based encoding tool. So how can we deal with all these tools play together nicely? Oh, sorry. I wanted to mention also these awesome projects. Dala, we are looking closely to what they're doing, and their success will depend mostly on how things wind up. Dash, we are using a special flavor of LSMesh and the libav format. We are currently working on having a HLS to Dash conversion on the fly. Of course, we are looking into HVC, so we are monthly testing X265 and see how they perform. Right now, it's still very slow. There is an order of magnitude, and so it's not possible to use it in production, but it's shaping up nicely. 4K, yes, of course, we are looking at 4K. We just offered 4K download, 4K and 2K downloads. Also, we're looking into high frame rates and adaptive streaming that we will deploy in the future in this year. Also, Opus is worth mentioning. We work together with Yusuke Nakamura, which is the LSMesh author, to have it standardized in an MP4, and it's finally ready. So as I mentioned, how do we get every nice collection of tools, open source tools, play nicely together? Well, we have some very strong policies and beliefs. We are not afraid of admitting that we use open source. Open source is great, and it's almost always beats any closed source solution. We work directly in the open source community. Most of our teams of the transcoding team is a member of the FFmpeg and libav projects. We believe that it's not possible to have an internal fork. It takes too much time, too much development effort to keep it updated, especially for libraries where the APIs changes so frequently. And one nice feedback is that we get a lot back from the community. We work together with them. By working together with them, we also get a lot from them, and it's not rare that the community helps us to get some features deployed. In short, we are collaborating with the people that everyone is working with, and being a jerk it benefits nobody, because nobody will see the improvements of your that you are trying to provide. As a matter of fact, there seem to be like two worlds that are fighting each other. We try to be on the good side, hopefully. We work with the upstreams. We try to report bugs and send patches. We try to release our software when there is no competitive advantage, and with an appropriate license. For example, we released the source code for some of our Go packages, and we did it with a BSD library, with the BSD license, in order to appease the community. We try to get our code across several projects without getting involved too much into politics. And when we get when we work together, we try to accept the patches from the community for the projects that we host. On the other side, there is this bad trend, which is more common than we would like to admit, that sometimes big corporations take use open source repositories just as code dump. Like they release this software and they forget about it, and they don't use it anymore. That's it's nice that they provided the source code, but without a community supporting it, it's very hard to have things working with it. There is a case that I like to mention. There was a C++ library that we developed a C API for, and this was our request was ignored for months until we contacted the author directly. We were prepared to rather have rather than having an internal fork, we were ready to have a separate library that would have interfaced with the library itself. But this is messy and requires additional work. With a proper upstream, you don't have this kind of additional effort. Then a lot of projects also are encumbered with the CLAs, and sometimes it's very difficult to comply with them. And some big corporation again claim ownership, and by that I mean they are the one controlling the source code, and I'm not sure this is the best practice for open source. Open source belongs to the community, not to a single entity. So, in conclusion, I allow myself to give some advice to any corporation that would like to use open source. Don't be afraid. The open source works. Vimeo has using open source with profit. It's like there is using a gem of open source tools glued together with a proprietary layer, but it's using and contributing back to the community. We are not shy of telling people that we are open source people, and we try to be a member of the open source community. And as of course, I try not to get involved too much with politics. I like to finish with a quote. Not everything that can be counted counts, and not everything that counts can be counted. Because I wanted to convey the fact that dealing with open source is something that it's really hard to measure, but it's really important. It's not something that you can put easily on a timesheet, for example, but it's something that in the long run and in the short run will improve your company, you as an engineer, and you as a human being. Thank you very much. Thank you.
Thank you very much. So we have almost 10 minutes for questions. So,
sure.
Or comments. So, yes, please.
As you mentioned, Vimeo doesn't do advertising. Where does it get its revenues from? Only from Vimeo on demand, or?
Yes, mostly from paid subscriptions and Vimeo on demand. Yes.
So it's a quick question. Oh, yes.
Do you extend an API? I assume you do.
Yeah, of course, there is an API.
Because for the streaming.
Oh, sorry.
Just rephrase the question.
if the question was if we have offer an API, and yes, there is an API which is enables you to use our services. Yes.
It's like a REST-based API?
Yeah, exactly. Yeah.
And you've got clients for various languages, various language bindings, or how does it work with them?
It's mostly HTTP based, and it has been released very recently. There should be a whole documentation on the website.
Other questions? Yes.
You were mentioning that it's bad practice to attempt to own a project while the project itself goes in the wrong direction in terms of technical governance. How do you deal with projects that go awry or with adopt a bad design? Would you try to discuss it or change and move to another project?
When this happens, usually open source has this great tool, which is forking. But that's only an extreme solution. Like usually, it's possible to work with your upstream, and
We have a problem. Overflow. Amazing. Next time we ask a bigger room.
nice.
Yeah. Sorry. Yeah.
Any other question?
I had a question regarding the licensing again. So, how do you deal with the MPEG licensing? Do you pay MPEG-LA individually, or for encoding and decoding?
I'm not exactly familiar with this. Yeah, probably, yeah. The thing is that the coding is mostly done on the decoding side, which is provided by the operating system. So basically it's moved to. Sorry, I repeat the question as well. What we do for related to MPEG-LA under the licensing problems for H.264. And can you hear me? The question was how to deal with how do we deal with the H.264 and its related licenses. The answer is mostly the coding is performed on the device end, so we let the operating system or device manufacturer pay the royalties for MPEG-LA.
Any other question to Vittorio? We have still time for. Yeah, we have still 10 minutes until the next talk. So, yeah.
You mentioned that you're encoding audio and video separately and then you're mixing them.
Mm-hmm.
I was wondering what's the reason.
So just repeat it.
The question is why encoding audio and audio separately. Mostly encoding performance. It's easier to have separate processes for audio and video, and also it helps us remove times desynchronization. Like if by encoding them separately, we are able to remix them with the right timings.
Regarding the usage of Go, could you tell us a bit about the transition, how your team using it, and if you're happy with it, or if there's anything you'd like to change, or be changed in Go?
So the question is how to deal with Go and its transition. Go is very powerful, and we really love it for a series of reasons. It's easy to deploy. It's easy to write a concurrent program. It's easy to test and have coverage for it. I don't have exact figures on how we are going to transition towards it, but we try to write most of our new code in Go so that we can start fresh.
Actually, I have a question about Go.
Sure.
Unless there's someone else with your question. You've said that you're dropping your Python and your JavaScript code for Go.
Mm-hmm.
I've recently read that there is like a trend of that, like abandoning Ruby and Python and a bunch of them and going with Go. advantages, like it being very structured, or is there anything else, the packages that it has, or?
So the question is how we're going to how and why we are dropping Python and JavaScript. Well, mostly it's a matter of also deployment, like having only C-based applications and Go applications is very easy, whereas Node requires installing Node's application. Python requires installing a lot of dependencies, so it's easier to deploy, but it's also easier to deal with. Having a single language to deal with is is an improvement from the development point of view.
So it's about development consolidation and ease of deployment, basically. Those
That's
are
the
major factors.
Yeah, exactly. It's easy of deployment and the consolidation. Yeah.
coworker. We also use Go a lot and our entire team C guys.
The entire team are C guys, which is one. What?
Go language makes our personal space a bit better.
Gotcha. You're saying it's an easy transition for C-based developers.
Yeah.
Going Go.
Any further questions? Well, thanks again, and
Thank you very much for your
thank you.